Okay, so 4.1 synthetic division, the remainder and factor theorems, day number 4. In day number 4, in this video, you are going to see two problems, both of which you are given a 0. You are asked to find the remaining zeros. Okay, so in this video, given a 0, you are asked to find the remaining zeros. I'm going to tell you right now, here is where your factoring skills will come into play. So if you want to take out that graphic organizer, you are going to need it. Okay, so let's take a look. Letter G. I tell you that 1 is a 0 of that polynomial. I ask you to use the factor theorem to help find all other zeros. Okay, so some things that I want you to think about, some things that I absolutely would put in my notes. First thing, your highest exponent tells you always how many zeros are in each and every single problem. So because this is x cubed, I know that there are 3 zeros in this problem. I'm already given one of them, which is right here. I'm already given that positive 1 is a 0, so that means I need to find 2 more zeros. Okay, so let's show you how to do this. If you think about what we did yesterday, I told you that 1 is a 0. That means if it is a 0, I must get a remainder of 0. Okay, if it's 0, that means it's a factor. Think about what the factor theorem said from yesterday. Think about those 2 bullets. If you need to look back and refresh your memory, great, look back at those, the factor theorem, those 2 bullets. I'm telling you that 1 is a 0. Based on the factor theorem, I want to show you, I'm going to kind of go a little bit out of order. Given that positive 1 is a 0, think about the factor theorem. It said that x minus 1 then has to be a factor. If 1 is a 0, the x minus 1 needs to be a factor. All right, so what does all this mean? What should we do? Well, I'm telling you that 1 is a 0, so 1 is the number that I should use when doing my synthetic division. Think about the difference. I'm telling you that positive 1 is a 0, so that's the number that I'm going to use. Think about your synthetic division. I'm looking at each term. Are there any terms missing that I have to worry about putting a 0 in its place? You should be saying, nope, no terms missing. So because there are no terms missing, what I'm going to do is simply list them there. Synthetic division, you should be experts at this point. Bring down that first number, multiply, add. So I'm just going to kind of get right to it. So because I got a remainder of 0, that tells me that this positive 1 is obviously a factor, or it is a 0. Well, I gave you in the problem that it is a 0, so I better have gotten a 0 remainder, and voila, I did. So from here, think about it. I know that 0 is my remainder, 12 is my constant, negative 12 is my constant, negative 4 is my x, and positive 1 is my x squared. So I'm going to write that down. It asked me to find all other zeros. So what I did is I set what I had left equal to 0 because I want to figure out what makes it 0. Okay, so from here, I'm going to look at what I have left, and I'm going to ask myself, can I factor this problem? Think about your thought processes. All right, step 1, can you factor anything out? Nope. Step 2, do I have difference of squares? Well, I don't have 2 terms, so that's out. Do I have perfect square trinomials? Are there 2 numbers, the same 2 numbers that multiply to get 12? Nope, so that's out. Step 3, do I have more than 4 terms? Well, that's obviously out. So it's got to be that step 4. Think we had that A, B, C, and D. This is actually the case of letter A because my leading coefficient is a 1. So that must mean that the way that I factor this, I find 2 numbers that multiply to get this. Those same 2 numbers have to add to get this. Okay, so 2 numbers that multiply to get negative 12, add to get negative 4. Obviously, it's negative 6 and positive 2. Think, what makes this equal to 0? What makes this equal to 0? I think I can handle that. It's 6 and negative 2. So guess what? There are my 2 zeros that are missing. Here was my first one. Here is my second one. Here is my third one. I said right in the beginning that I better get 3 answers. Look at that. 1, 2. There are the 3 zeros of this function. So understanding, you're going to set up your synthetic division to get you down to something hopefully that you can factor to find the remaining zeros. Notice I asked you to find all other zeros. These would be the other zeros. You're already given the 1, so there are the other 2 that you need to find. Okay, let's try another one. Letter H. I tell you that 2 is a 0 of that function. I ask you to use the factor theorem to help find all other zeros. How many other zeros are we going to need to find in this problem? Well, you should be saying to yourself, there need to be 4 total. I'm only given 1 of them. That must mean I need to find 3 more zeros. How the heck do I do that? Well, same deal. I'm going to set up my synthetic division. I'm going to look at my function. Are there any terms that are missing that I need to hold their place? 4, 3, 2, 1, 0. Looks like nothing is missing. So I'm just going to set up my synthetic division. I'm going to go ahead and do my synthetic division. Notice that I got a 0 remainder. Guess what? If it says that 2 is a 0 and you don't get a 0 remainder, guess what? That means you absolutely did something wrong. So that's a good way to check yourself. All right, so think about what we're left with. I know this is my remainder, my constant, my x squared, and my x cubed. So if I think about writing that down, there they are. I'm going to write it. All right, so it said find all other zeros. That's why I set it equal to 0. All right, so that must mean I got to be able to factor this sucker. Well, hopefully you're saying to yourself, please tell me you're getting better at this. I see 4 terms. I'm automatically thinking, look at your graphic organizer. I'm thinking that I have to be able to group these. So I'm going to try to group them. Okay, when I factor by grouping, good news for you is that I'm going to go over it in detail one more time. Okay, so if I factor by grouping, I group the first 2 and I group the second 2. What can I factor out of the first group? Well, I can factor out an x squared. If I factor out an x squared from the first group, what am I left with? I'm left with x plus 3. Second group, what can I factor out? Well, I'm going to factor out a negative 4. Why negative 4 instead of positive 4? Well, look, there was a minus sign in between here. So that's why I'm just going to carry down that minus sign. So technically I'm factoring out a negative 4 and not a positive 4. So if I factor out negative 4, what do I have left? I have x, because negative 4, think about it, negative 4 times x is that negative 4x I was looking for. And I have positive 3, not negative 3, I have positive 3, because if I think negative 4 times positive 3 is my negative 12, and therefore that's why it should be like that. Okay, so remember, when factoring by grouping, these will always be the same. If they're not, you cannot possibly factor it by grouping. But because they are the same, I can take this one step further. I'm going to put the x squared minus 4 together. I'm going to tack on the x plus 3, and I'm going to set that equal to 0. All right, am I done? I don't think so. This is causing me some anxiety here because it's not linear. Good news, the way that you'll be able to tell if you are completely done factoring, each term should be linear, aka x to the first power. So because this guy right here is not x to the first, I know I can probably factor this. So I'm going to go through my thought process. Step 1, can I factor anything out? Nope. Step 2, do I have difference of squares? I absolutely do. I have difference, which means subtract them. Squares, x times x, 2 times 2. So it looks like I have x difference of squares. How do you factor difference of squares? Well, 1 minus and 1 plus. So that's how I factored this. I just tacked this on, brought it down. So now I'm saying to myself, okay, with these 3 terms here, what makes them equal to 0? Well, positive 2, negative 2, negative 3. I said in the beginning I needed to find 3 more. Voila, there are the 3 more. I said there needed to be 4 total. 1, 2, 3. There are 4 of them total. Okay, so G and H, what we did is I gave you a 0. You had to find the remaining zeros. Hopefully your factoring skills are up to par, and you got whatever you needed to get out of this. You wrote yourself some questions. You wrote yourself some notes. Please, let's not be lazy. And good job.